Good morning everyone, today I'm going to talk about the project that I have made called Reverse Mario for my programming project. Starting off with my pseudocode. Pseudocode asking first the user what maze number that you would like to solve from 1 to 6. We have 6 mazes. Then we asking the user to put the entrance cell, then the exit cell. Then we start from the entrance cell. Then we mark the cell that haven't been visited by adding 1 to its value, and we add only 1 to the arrays that has only zeros. If the cell is exit that we selected as an entrance, then we jump to number 9 and we retrace the complete path and we print all the cells that Mario used to go to the exit. And if it not, we select all the adjusted cell which haven't been visited by comparing them. So we see the array that haven't been visited, which is zeros, and the array that has been visited, which is ones, and we go to the one that is equal to zeros. For each of the selected cell, go to number 5, which is if it's the one haven't been to, then go to number 5 and mark it visited. Once all of this happens, we come here to number 10. While we checking for the path, we see if there is more than 3 direction for each cell. We check each cell and see if there is more than 3 moves. Direction that Mario can go through. Then we add this location to the list of the junction. Then we print all junctions. And here is the end of my pseudocode. We start off now with my code. I have made 3 user-defined functions, and the first one is called print maze, and I use it to print the maze off by using 2 loops and array by using 2 loops and array in between them, so we could print the whole maze. And the second one is user-defined for only to find the path. I'm gonna talk about it later, and has 1, 2, 3, 4, 5, 6, 7 arguments. And last one is find G, which is for finding the junction. And find G has 5 arguments. So we start off with the main function, and we have made this maze, which is the maze that we targeted each time. So 6 mazes, and each maze has this size. We made these for a for loop, and here is the steps to open up a file. So we read in all the mazes from a text file by using the mode read, and we need all of this in order to we need all of this in order to take all the information from the text file and put it into maze text, which has a 20 rows and 20 columns and 22 columns. So 120 rows and 22 columns, which is the whole 6 mazes put into this text maze. And now we use the help of our friend fgets, so we could read the whole text file. And while we read the text file, so this fgets gonna read until the end of the line. So we're gonna take this line and put it into the double scanf. The double scanf gonna chop the 22 numbers into 20 integers and save it into call. Save it into these, and once it has been saved, we're gonna use this for loop to save it into the matrix. So basically this call gonna put each row into the matrix, and we're gonna take care of increasing the matrix by this one at the maze text file. Once this finished, this is all just to make sure that the file was closed properly. And here asking the user which maze you would like to take. So if you choose 1, we're gonna use this if, which is basically gonna say there is nested loop that's going from 20 to 22, and this one is for the row, the I is for row, and the J for is the column. and we're gonna take it from the big matrix, which is the first. So we're gonna take the first 22 rows. Here, if we asking for the second, so you want the next 20 of them. So it's gonna go from. So here is the row gonna go from 20 to 40 for the big matrix. So we are just targeting the second maze. So we're going from 20 to 40. So we're targeting this one, and here we put minus 20. So that does not affect the size of the maze, our maze, which is only 20 and 22. So and so on for each one of them. If you put 3, so we're gonna take the maze number 3, and here is 40. So because we're only targeting. So from 40 to 60, so we're only targeting at the big matrix, we're only targeting the third one, and we only wanna we don't wanna mess up the maze. So because only has a size for 20 rows, not 40 to 60. So we just put minus 40 here to make sure that it's only 20. And here is for the 4 and 5 and so on. And here we print off the maze by using a nested loop. I'm gonna show it to you later. Well, we use here a user definer, and here asking the user to what is the entrance, what is the location for the entrance. Once you put the location for the entrance, they're gonna make sure that it is at the first column or at the first row by this if function. And this while loop gonna make sure that you finished this this condition. So if you don't choose the right one, so it's gonna keep looping until you choose one of these are satisfied. So on here. If the while loop, so if the benefit of this while loop is only to make sure that the thing that you chose, the interest that you chose, is equal to 1. If it's not, then it is a wall, so you have to re-enter the entrance. And here you put the exit cell, and here you make sure that the exit cell are the last row or the last column by using this if function and using this while loop to make sure that you put it right, and to make sure that the entrance that you put was a path, not a wall. And here we print off the maze again by using the user definer, which has a nested loop that could print the columns and the row by using the nested loop. And here I use something called direct that I use so in order to only print each time Mario takes turn. Otherwise it won't print. So I use something called direct. And here is the thing that I made for the finding a junction. So I have made called XZ and YZ, and this has 200, so size of 200, and which is basically gonna read from this. So these two nested loop what we're gonna do is the two nested loop gonna work, and this if function gonna work once it's see. So if the maze that we chose, let's say maze 1, maze 2, maze 3, if the maze that we chose and while the loops is going, if the cell that we chose is equal to 0, then go here and mark XZ to equal to the row, and XY to equal to the columns. And here is the increment for these two arrays, which is the S. Once we finish from this one, we go to find junction. Find junction gonna basically come here. Find junction. Here is the find junction. Here's the user defined for the find junction. We made all of this, so basically to check if there is if in each cell we check if there is more than 3 direction. If there is more than 3 direction, we take we print this cell. We print this cell as a junction. So, and here is the following. So we start off as a for loop, and this for loop started from 0 to the s, and s is has been added. It's equal to the number. It's equal to the number that we made over there. So S basically is gonna be incrementing each time this loop runs. So we don't know how much is gonna be S exactly, but whatever it is gonna be in here. So the direction here is equal to 0. Here is the f function. Here is a f function. What it's gonna do is gonna check the location of the raw, of each 0. I'm gonna check down by this one. Gonna check up in this one, and if it's equal to 0, add 1 to the direction. Then here you're gonna check down at the maze, and if the maze is equal to 0, then add 1 to the direction. Then here gonna check to the left, and here gonna check to the left, and if there is a left is 0, then add 1 to the direction, and here so on. Here gonna check down at the same cell, gonna check at same location, gonna check down and see, oh, there is it's equal to 0. Then we add the one more to the direction. Here we say if the direction is 3 or more, which is then mark this as a junction. So the JX gonna take the location from the XZ, and the JY gonna take it from the YZ. And here is the increments. So to make sure all of them increment. Once all of this happens, and once we took all the junctions from the whole array, we just come here and print them all by using this for loop. And this for loop are going from 0 to the I, and this I is the increment of the JX and JY. And now we have all these f functions. So the first f function gonna check for the down cell and gonna compare it with the right and left and above, and gonna check and make sure that if the down cell for the entrance that we put for all the entrance, which is x and y, the entrance location that we put, and we check for the right and left and down, and if all of them are larger or equal, then this thing gonna happen, which is XL gonna equal to the x plus 1, and LY gonna equal to the y, and XC plus 1 because it's going down. So we add 1 to the raw, so it's go down. And here else if to check for the right. So the same thing. So X and Y that has been entered from the user, and we check here for the right cell, and we compare it with the left. We compare it with down and left and above, and we check if they are all larger than the right cell. Then we come here and put XL and LX equal to X, and LY equal to Y plus 1, and we add plus 1 to the Y, so we move on to the next right cell. and here the same thing for the left, and here the same thing for above. Gonna compare the above with down, gonna compare the above with the right and down and left, and the same thing here happens. So the left can add -1 to the x. If here check if the x if the x entrance equal to the x exit and and the y entrance equal to the y e, which is exit, return. So like terminate the whole user defined, and that's it. So don't do any more work. And if it's not, we're gonna go into these loops, and these while loops gonna basically for this one it's only made for the right. So we have 4 while loops for each direction. So we're starting with this one, which is the right one. So the right one is basically is never gonna work unless the f one of these if function is working, and all these if function is if and else. So one of them gonna work at a time. So if one of them working at them, let's say the right one was the only one that satisfy the condition for the else if. So we're gonna check here x equal to the lx and y plus 1 equal to ly, and this is true because if else worked, then we're gonna add 1 to the ly. So this while loop should work fine if the f function was satisfied. So once the while loop works, we're gonna go for the maze cell that we chose, and we're gonna add, and we're gonna go right. Once we go right, we're gonna add to that cell, we're gonna add to its value a 1. If we add 1, just to mark it visited, and we add and we incremented the y. So we go right more and more and more and more. And here check if the direct does not equal to 0, which is true because we put direct equal to 2 at the beginning. So if it's we made 0 direct for the horizontal, and we made 1 for the vertical. So if it doesn't equal to 0, then print this one. So we're gonna print each time. It takes a turn. So now it goes to the right, so it takes a turn. So we're gonna print that. Once it's gonna print it one time, and gonna make direct equal to 0. So now it's not gonna print unless it's go up or down. So now we check again if x entrance equal to the x exit, and y check if it's yes, then print the last cell and break this loop. And here we have this one at the end of each while loop, so it's updates all the locations for the x and y, so update it every time. So once the while loop end, it's gonna come here and gonna start all over from the beginning. I'm gonna come here and gonna start from here. I'm gonna choose one of these f's again, right and left, right and left, right and left, until it reaches the end of it. So and you may wonder why I made this change. I made this change because my whole program is working based on comparing the values, which is in here. So once we compare the values, so my code gonna go all over the maze. I'm gonna check all the path that has 0. So we don't want the program to go at the same path more than one more time or 2 times maximum. So each time that Mario passes or go into a cell, we're gonna add 1 into it. And once we're gonna add 1 into it, so that means the value of that array is increased, and that means once we compare it, once we use this if to compare it, we're not gonna select that path because the value of that path increases. So that mean it's not gonna satisfy these ifs. So if we so like if going so if we already went down, we won't go down again, because once we compare the values, we're gonna see that the 0 less than 1. So we're gonna go with the path that has only zeros and not 1. So, and this basically the how he find the path. And I want to talk about, yeah, and here is, let's say here is going up. If it's going up, it's gonna go throughout the f function and make sure that it satisfies the condition that all the other all the other above cell of the above cell, and check all the other the one next to it are larger than it. So, and come here, and once you come here, the while loop gonna work, because it's gonna satisfy the conditions, and we're gonna go up by minus by putting minus to the x at put minus at the r. Or we're gonna are we gonna keep putting minus, so we're gonna go up and more. And here is plus 1 1. So we add value to that array. We add 1, and here we check if Mario has been moving all the time horizontally. So that means that the direct has been equal to 0 all the time. So that means when it comes to this if and see, and now he's going at the top, and now he's going above up. So we're gonna check if direct does not equal to 1, and this is true because direct equal to 0 now. So we're gonna print this and gonna make direct equal to 1. I'm gonna make direct equal to 1. And once you're gonna make direct equal to 1, now it's not gonna print again as long as going above or down. And here to check if our moves made while we moved, is this move was the last move, by checking the x interest and x exit are equal or not. And if they are, then we print the last one, and we add here the index, because the index here are zeros, so we make it as a human, so we add 1 to here and 1 to here. And here's the break, so we break the loop out, we finish. And here is the junction again. And I want to show you last thing is basically about yeah, and here is the print maze. Print maze basically has an integer of I and j, and these are all both are nested loop. And here is the raw, which is I think 20, and here is 22. And we use this, so like each time the raw has been filled, we go to the next raw by going to the next new line, but by making a new line. So we go to the next raw and we fill it, the whole columns, and so on. And this is the whole thing, and this is my whole script. I hope that you like it. Don't forget to put a subscribe and like, and thank you so much, and you have a great rest of your day. Last thing I forgot to really talk about this one. I made each 5 to 20 because sometimes at maze 5 and maze 6 we have Mario gets stuck on one of the paths, because one of the paths like are just like he go back and forth at them. So sometimes like he increase the sail by 5 and 6, and once that happen, and he gonna compare it with the walls, so he gonna think the wall gonna be path. So I made this 5 equal to 20, so to make sure that no matter what, how Mario like passes throughout the cell, will never reach it 20 times. So we'll never consider the walls as paths. So that's the only reason that I made it. And now Thank you so much, and you have a great rest of your day. I appreciate it, and seriously, the like.